Welcome to this tutorial on matrix inverse using NumPy. In this video, you'll learn how to find the inverse of matrices using NumPy's linear algebra module. We'll be using the np.linalg.inv function, which is a powerful tool for matrix computations. Let's start with the basics. What exactly is a matrix inverse? The inverse of a matrix A is another matrix that, when multiplied with A, gives us the identity matrix. Mathematically, we write this as a times A inverse equals I, where I represents the identity matrix. Think of it like how multiplying a number by its reciprocal gives you one. Matrix inversion is similar, but for matrices. Not all matrices can be inverted. There are two important requirements. First, the matrix must be square, meaning it has the same number of rows and columns, like a 2 by 2 or 3 by 3 matrix. Second, the matrix's determinant must be non-zero. If the determinant is 0, the matrix is called singular and cannot be inverted. Now let's look at the syntax. First, you import NumPy as np then. To find the inverse, you write inverse underscore matrix equals np.linalg.inv and pass your matrix as the argument. It's that simple. The function returns a new matrix that is the inverse of your input matrix. Let's work through a practical example with a 2 by 2 matrix. We create matrix A using np.array, with the values 4, 7 in the first row, and 2, 6 in the second row. Then we calculate its inverse by calling np.linalg.inv on matrix A, and store the result in a underscore inv. Finally, we print the inverse matrix to see the result. Here's what the output looks like. The inverse matrix contains the values 0.6 and -0.7 in the first row, and -0.2 and 0.4 in the second row. These decimal values might look complex, but they're the exact values needed to satisfy the inverse property. It's always good practice to verify your result. You can multiply the original matrix A with its inverse using np. Store the result and print it. This multiplication should give you the identity matrix, confirming that you've correctly calculated the inverse. The identity matrix has ones on the diagonal and zeros elsewhere. Before we wrap up, here are some important points to remember. If you try to invert a singular matrix, NumPy will raise a linalg error. Matrix inversion is computationally expensive for large matrices, so use it wisely. It's commonly used in solving linear equations. However, for solving equation systems, consider using np.linalg.solve instead, as it's more efficient and numerically stable.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.